Alright, for 12.5 day 2 homework help, I will go through 3 problems that are similar to the problems that you have in the homework, where we are finding the area under the curve of a particular function from 0 to 1. Another function where going from 0 to 2, and like we mentioned in class, it's a little bit easier if the a value or that first number is 0. So the last one that we end up doing then will be, what do I do if I don't have an a value of 0, and it makes it a little more challenging. It just means you'll have more probably algebra involved. But overall the idea is the same. So of course the first thing you have to understand is whether I say this or not, you have to do this using the limit process. So when it says to find the area under the curve of this function, you have to remember kind of how we set this thing up. So we are going to start by saying it's the limit as n approaches infinity of the sum as I goes from 1 to n of f of, and now your formula is a, which in this case is 0, plus b minus a, which is 1i over n. And remember what that's doing is that's technically finding the height of all those little rectangles that we kind of drew when we were looking at the example of how the limit works for finding the area. And then it's times b minus a over n. And I said kind of as a general rule of thumb, when you are looking at these two, they should always be the same, other than this one has an I on it and this one doesn't. Alright, so that's the setup. So that's what we had to learn today. That's the one step that we have to learn. Now we have to do some simplifying. And of course the biggest thing you have to catch right away is this. It's f of that quantity, which technically it's not a quantity because I don't need to put the 0 there, which means I have to plug this in for x in the equation. So as I'm showing my work here, I have the limit as n approaches infinity of the sum as I goes from 1 to n of, figuring out this part of it, I put a bracket around it just to separate it from this. If I plug I over n in for x, I'm going to have I over n squared plus 2. I basically just have to copy that function down. So that is what this is equal to. If I plug I over n in for x, this is what I would end up with, and now I still have that 1 over n. And the only reason I use a bracket is to separate this from this. Once you get it to here, it's basically what we did yesterday. Now your job is to simplify this if you can, and then once you're done simplifying, distribute the 1 over n. So simplifying this, there's not really a whole lot I can do to it, and I wouldn't necessarily need to see this step if you didn't want to show this to me for this particular problem, because there's really not much you're going to do here. Just going to square these individually and say it's I squared over n squared, and then still have plus 2. Now some people want to get common denominators. You can do that. I would recommend not doing that. I think it's easier just to keep these two things separate. Now I'm going to go ahead and distribute the 1 over n. So I'm going to have the limit as n approaches infinity of the sum. Now if you want to save yourself some work here, you can do that. Remember that I'm going to distribute here and then I'm going to break them apart. I'm going to go ahead and just do that and say it's I squared over n cubed. Distributing here I get 2 over n. And then from there, I'm going to break them apart. So now I've got the limit as n approaches infinity, parenthesis here now because I'm splitting these apart, it's going to be the sum of, and if you want to kind of save yourself a step, I'm going to be factoring out the 1 over n cubed so that I have the sum of just I squared left, plus I would factor out the 2 over n, and that technically would leave me with the sum of just 1. So now I'm looking for the limit as n approaches infinity of, got 1 over n cubed, and now I can use my formulas to change this into n plus 1, 2n plus 1, all over 6, plus 2 over n times just n, because this is a constant. And now the good news is, the difference from here compared to what we did yesterday is when I get here, we had to get common denominators and combine them and do all that. I don't have to here. If you look, you can see I've got 3 n's in the numerator. So if I multiplied it all together, I would have in the numerator 2n cubed plus some other stuff divided by 6n cubed if I didn't do any simplifying. And remember, since I'm finding the limit as n approaches infinity, I don't really need to know what this is simplified. I just need to know what the limit of it is. And the plus sign separates it. I've got one gigantic term here a second term, I just find the limit of both of those separately and then I'll add them together. So the limit of that first one is 2 over 6 or 1/3 plus, that would simplify just to 2. So now I just have to add these together. This is 6 over 3, or that's eventually going to give me 7/3. So you don't have to do that like we did the last couple days where I simplify this down to one equation. All I need to do is find the limit of that term separately, which you have 3 n's, you have 3 here. That's why the exponent on I has to be 1 less than n, so that will end up happening. That's why if you don't see that, chances are that means you've done something wrong. Alright, so using the same idea, let's do the next one. Using the limit process, so again, I've got the limit as n approaches infinity. Of course, when you're reading through it, it's that's telling you to do this and trying to find the area under the curve. Limit as n approaches infinity of the sum as I goes from 1 to n of f of, and now it's a is 0, so I don't necessarily need to write that. It's b minus a, so it's going to be 2I over n times 2 over n. So set up exactly the same as what I did here. It's just that because this is 0, I don't realistically need to write that. Alright, now in terms of your simplifying, I would start with that first. I need to, because it's f of, I need to plug this in, and notice I'm plugging it in 2 places here. So I've got the limit now as n approaches infinity of the sum as I goes from 1 to n of 2I over n, so it's 4 times 2I over n minus 2I over n cubed. And again, if there was a plus 7 or something like that, you would need to have that inside this bracket, and then you still have the 2 over n. So all I've really done is taken this bracket and simplified it, taken this and simplified it to that bracket. Now I'm going to continue to simplify as far as I can. So I've got the limit as n approaches infinity of the sum as I goes from 1 to n. Inside that bracket, it looks like I have 8I over n if I multiply and simplify the first term. These are all being multiplied and divided, so I can cube them all separately. So it's going to be 2 cubed, I cubed, and n cubed. And now since I've got everything in here simplified as far as I can, I'll go ahead and distribute the 2 over n. So I've got the limit as n approaches infinity of the sum as I goes from 1 to n of, distribute, it's going to give me 16I over n squared. Again, I noticed that I to the first, n squared, that's good. Minus, this is going to give me 16I cubed over n to the fourth. Cubed fourth, that's good. And now I can go ahead and split these apart. So I'm going to have the limit as n approaches infinity of, again, saving myself a step, I'm going to factor out the 16 over n squared, and I'll be left with the sum of I minus, factor out the 16 over n to the fourth, and I'm left with the sum of I cubed. Sorry if I'm getting a little messy there. And now I can go ahead and simplify even more, so I've got the limit as n approaches infinity of, this is 16 over n squared, the sum of I know will change into n plus 1 over 2, and again notice that would be n squared, so all I have to do is really divide the leading coefficients, minus 16 over n to the fourth times, this one we don't use very often, so make sure that you look that one up, it's I cubed, this is n squared times n plus 1 squared over 4. We tend to use I and I squared a lot, but we don't use this one as often, so make sure that you're comfortable with that one. And now I'm trying to find the limit as n approaches infinity, so I know this is going to give me n squared, so really I'm just dividing the leading coefficients to get 8. That's going to give me n to the fourth if I multiplied it out, n to the fourth, divide the leading coefficients. My answer for this one is going to be 4. That would be the area under that curve in that interval. Alright, so if we kind of got this down, let's see if we can apply it now to one where there's going to be a lot more algebra involved. So now my a value is not 0, which means, like I said, there's going to be a little bit more algebra to do here. So setup is still the same. It's the limit as n approaches infinity of the sum as I goes from 1 to n of f of a, which is negative 1, plus b minus a. This should always be a positive number, so 1 minus a negative 1 should give me positive 2I over n times, remember, it should be the same thing, 2 over n. So there's your basic setup using that area formula. Then remember, you want to start here. It's f of this quantity, so that quantity has to get plugged in for both of those. So I now have the limit as n approaches infinity of the sum as I goes from 1 to n of x squared, so that means it's negative 1 plus 2i over n quantity squared, minus x cubed, so the quantity negative 1 plus 2i over n cubed. There is that function, x squared minus x to the third. Again, if there's a plus 2 or 7 or something like that, you need to have that in there. And then you still have this 2 over n. So what you see in brackets is what I have in that box up above. Now my job should be to multiply this out as much as I can, or simplify as much as I possibly can. So I got the limit as n approaches infinity of the sum of I goes from 1 to n of, if I multiply or FOIL that out, that's going to give me positive 1 if I square. Multiplying those two together gives me negative 2i over n. That's the insides. The outside's same thing, so I have a total of negative 4i over n. And then squaring that last term, make sure you square everything. It's 4i squared over n squared. Minus, now I've got to do that quantity cubed. So maybe you want to off to the side kind of do this out by hand. There's the quantity squared. So 1 minus 4i over n plus 4i squared over n squared. There's the quantity squared. I need to multiply it by another negative 1 plus 2i over n. So if I distribute the negative 1, that would give me negative 1. It would give me a positive 4i over n. It would give me a negative 4i squared over n squared. Distribute the 2i over n, that's going to give me a positive 2i over n. This is the like term. It's going to give me a negative 8i squared over n squared, and it's going to give me a positive 8i cubed over n cubed. And so now I just have to add and combine like terms. So what is this? Make sure you've got the negative here. It's negative 1 plus 6i over n minus 12i squared over n squared plus 8i cubed over n cubed. And then I still have that 2 over n sitting out here. So there's FOILed it out, or squared. Here the thing is cubed. Now, before I distribute that 2 over n, I'm going to simplify one quick step here. I'm going to distribute the negative, and I'm going to combine like terms. So that would become a positive 1 plus 1, or this should be 2. I've got negative 4i, distribute that negative to the 6, it's going to give me a total of negative 10i over n. I have a positive 4i squared. This is going to become positive 12, so plus 16i squared over n squared. And then I'm going to have a negative 8i cubed over n cubed. And then I've got the 2 over n. And if you're worried about this exponent's not one larger, that's fine. We still have to distribute that, and that'll make that happen. Alright, now I can go back and find the limit as n approaches infinity of the sum as I goes from 1 to n of, now I'll finally distribute that 2 over n in. So now I've got 4 over n minus 20i over n squared, now I've got the exponents like I want them to be, plus 32i squared over n cubed, minus 16i cubed over n to the 4th. And now I can pull everything apart. So I've got the limit as n approaches infinity of, I'm going to factor out the 4 over n, which would leave me with a 1. So there would be a 1 here, minus factor out the 20 over n squared, which is going to leave me with the sum of just I, plus factor out the 32 over n cubed. That is going to leave you with the sum of I squared. Factor out the 16 over n to the 4th, and that is going to leave you with the sum of I to the 3rd. And so now I have the limit as n approaches infinity. Now we use those properties again to figure out what each of these little sums are. It's 4 over n. It's a constant, so you just multiply it by n. So it's 1n. Minus 20 over n squared times, sum of I is just n plus 1 over 2, plus 32 over n cubed is the next one. Sum of I squared is n plus 1, 2n plus 1 all over 6. And then the last term is negative 16n to the fourth. Sum of I cubed is n squared. The quantity n plus 1 squared over 4. And now, like should happen, all of these should simplify nicely so that we can figure out what the limits are. The n's would cancel. My limit as n approaches infinity of just a number is just that number 4. Minus, this would be n squared, so it's 20 over 2, so minus 10. When you do this term, the term that's got the 3 terms, you have to be careful because it's easy to forget about that too. My recommendation is to cancel those right away, and then you can look to see if that will simplify. But that is the most common mistake, forgetting that 2, because you're used to just dividing these two, and you'll do it for all of them except for this one. So this is going to be 32 thirds that I'm adding, subtracting 16 over 4, or 4. So 4 and negative 4, of course, those cancels out. I can change that to negative 30 thirds plus 32 thirds, or the limit as n approaches infinity, which is the same thing as the area under the curve, is 2 thirds. So if I actually drew that picture, which I'm not going to actually draw it, but here, let's say it looks something like that. I go from negative 1 to positive 1. This is a bad picture. Yeah, ignore it. Let me just make something up that will kind of make sense. Let's say that's the graph. Here's negative 1, here's positive 1. If I found the area underneath that curve, it's saying that it would be 2 thirds of a unit. Alright, this is an excellent problem to look at. If you can find your way through all of that without making a mistake or making just a little mistake here or there, that means you've got a really good idea of what you're doing. Just make sure you practice it a little bit. But that is your homework help for 12.5, day 2. Feel free to come in and ask for help if you need it.